Let's take a look at the containerized cargo system and its system requirements using this stock and flow technique we've started using in previous videos. The point being the layout, a conceptualization of what our system needs to look like in order to go ahead and engineer our application. So we're still dealing very, very early in the systems engineering lifecycle. We're still just conceptualizing a system as you might want to work on it. So previously, we've talked at the higher level, at the stakeholder view, where what our customer stakeholders want is to move cargo amongst locations, shippers and receivers and consignees moving cargo around the world. So in that respect, our system, in terms of its mission, looks at every customer location as a site to which we can consign cargo and from which we will ship cargo. That's the perspective of our customers. They don't care what's happening inside our system. But now we want to go to that next level and ask ourselves, what kind of system do we have to have in place to implement and meet those customer requirements? So let's take a look at system requirements. The first is that implied by the name of our system, we're interested in containerized cargo. So we're very interested in containers. So one of our system requirements is that we have to be able to take cargo and put it in and out of containers, which makes the container a stock. So we want to be able to stuff cargo into containers and strip cargo from containers. Putting that together, the container becomes a key stock in our process for moving things around for the stuffing and stripping of cargo. So that means that our container is a stock. So we already thought of the customer location as a stock, but now we want to manage containers as stocks. For any given container, remember, a stock is something we can have more or less of something in. So a container can be anything from empty to full of cargo. So container is a stock of cargo as we go through. Then we want to take those containers and move them around, because that's the customer's point, is to move them among locations. So we have to be able to associate a container with a vehicle. That makes a vehicle a stock that can have more or fewer containers in it. So we want to be able to load containers into or onto a vehicle. We want to be able to discharge them from a vehicle, and that makes the vehicle our stock in terms of our management. The vehicle can be a truck, it can be a barge, it can be a train, it can be an ocean-going ship. It can be a lot of different kinds of vehicles. But basically, a vehicle is a stock of containers. You can have no containers on it up to the full capacity of the vehicle. So someone within our system is going to want to manage how many containers are on a given vehicle at any given time. That becomes a problem in our system. So a vehicle then is a stock in our system, which means that the container, which was already a stock in our system, is also a flow, because the vehicle doesn't care if the container is empty or full. The vehicle is a stock of containers, not of cargo, except obviously that if some of the containers on the vehicle have cargo in them, then you've got both. But a vehicle is a stock of containers. When I look at the ship at the port that's about to sail out to sea, I can see that it has thousands of containers on it. I don't know how many of those containers have any cargo in them. That's a different point. So a vehicle is a flow of containers. Then I want to get those vehicles among our different facilities, because obviously I'm going to serve my facilities from all over the world, and each of those facilities serves given customer locations, and that's where our attachment is to the customer. So I'm going to ship to a customer in central New Jersey, then I probably want to sail my vessel or take a train or a truck to Port Elizabeth facility in central New Jersey, from which the cargo will then be delivered. So I've got to establish my facilities. While I might have hundreds of thousands of customer locations, most organizations like ours might only have several dozen facilities around the world. A large company might have 100 or 200 facilities. But the actual system we're going to build needs to be built around our facilities. We want to make sure we plan for facilities that in fact provide service to the locations we're trying to meet for our customer. And since those customer locations could be anywhere, we're going to need a network of facilities all over the world from which we can serve those customer locations. So a facility then is where our trips go. So when a vessel sails from Port Elizabeth to Amsterdam, it's an inbound trip to Amsterdam, and it's an outbound trip from, say, Port Elizabeth or Port Jacksonville. So facilities are places that are the destination or origination point for the different trips that are going on as we move our cargo around the world. So those facilities are serving customer locations, and they're serving as the starting or ending points of the different trips we're trying to manage. So that makes the facility a stock over time. It's a facility of stuff, of containers that are going to be delivered to customers, or it's a stock of containers that have been received from customers as we go through. So again, the container becomes the flow that needs to be managed at that level. And then finally, we have routes. Our vehicles have to follow routes between facilities, some of which make sense, some of which are illogical. So there isn't necessarily a route between any two facilities, but the routes will be of different types. So the route is what the vehicle follows when it's trying to move between facilities. So if my truck leaves Port Jacksonville to go someplace, say westbound on I-10, it has departed my facility and is now en route to wherever it is going. Likewise, it will eventually arrive. It will leave the route because it arrives at the place where it's trying to go. So the route between facilities is a stock of the vehicles that are moving among the facilities as we go through. So the route becomes my stock, and it closes out my system requirements loop. I've got cargo that flows by moving in through containers, which are moved onto vehicles, which follow routes that end up at facilities that serve the locations. So from the point where cargo is being shipped from the customer to the next customer location it has to go, I now have a closed loop and things going on. And this diagram also illustrates just how complex the system we're trying to engineer actually is, because there are different layers of system here. And by layer, think of it in terms of there are going to be functions you've got to define. There are going to be stakeholders who are interested in certain kinds of questions and certain kinds of activities. There'll be managers who are responsible for certain things as they go through. And the fact that it's multiple flows in your system is your visual cue that this is a very complex system. Very simple systems tend to be the flow of one thing through the system. But in this case, I've got 3 different flows depending upon how I choose to look at it. So part of my main system is focused on moving cargo around the world. That's obviously the level at which my customers are interested. But anyone who manages cargoes, like at a consolidation center or a customs inspector or a ship's captain who has to know how much hazardous cargo is on board. There are people who are interested in the cargo itself as it moves around the world. So there'll be lots of functions and capabilities of our system that are trying to manage and control the movement of cargo. But there will be other functions and controls in our system that aren't concerned with the cargo itself. They're just concerned with the containers. Where are the containers? How are they stacked? What kind of condition are they in? Are they loaded or unloaded? Which ones are in transit? Do I have enough empties in the north to serve the need next month? There's people who just manage at the container level. So the movement of containers is itself a major function of my system. And then finally, there are people who are interested just in the vehicles, not in the containers themselves. So did my truck leave on time when I dispatched it? Do I have a vehicle to go pick up some item at a customer location? Did the vessel sail on time? Am I making progress through my route the way I'm supposed to? So there are people, dispatchers and transportation controllers, who are just interested in the vehicles as they go through. So the system is very, very complex. We'll have to manage the locations, the facilities, the routes, the vehicles, the containers as stocks, and we'll have to plan and control and process the cargo, the containers, and the vehicles as flows. So we tend to manage the stocks, we tend to process and control the flows, and it's that combination of things that constitutes the scope of the system requirements we need to write for this system.